This is Dr. Pi Channel. Welcome to listen to the important semiconductor news from August 30 to September 6, 2025. This week, we're looking at a market that isn't just growing, it's literally exploding. And it all starts with one massive new forecast that really sets the stage for everything else we're going to talk about, the industry's march to a $1 trillion future.
So let's just jump right in. We're starting with one number. A single, absolutely stunning number from a new forecast that is going to redefine the next decade for our industry. For anyone who's a practitioner or an investor in this space, this is it. This is the figure that matters most. $1 trillion.
So where in the world does that giant number even come from? Well, a brand new report from PwC is projecting that the global semiconductor market will blast past the $1 trillion mark by 2030. Now, to put that into perspective for you, right now we're sitting at about $627 billion. To get from here to $1 trillion, the entire industry has to grow at a compound annual rate of 8.6%. That's not just steady growth. That is some serious, sustained acceleration for an industry that's already massive. This isn't just a cycle, folks. It's the dawn of a golden era for both innovation and investment.
So what's the rocket fuel behind this $1 trillion wave? PwC points to two main engines. First, you've got server and network chips, growing at a blistering 11.6% a year. And that's pretty much all thanks to the insatiable, ravenous demand for compute from generative AI. Right on its heels is automotive, clocking in at 10.7%, as our cars basically morphing into data centers on wheels. These are the two golden tracks for the industry. But, a prize this huge, it's never won without a fight. And that brings us to the new chip war. The new chip war, a geopolitical battlefield. Yeah, a battlefield is exactly what it's becoming. See, when you have a pie this big, with this kind of mind-bending growth, it's never gonna be a peaceful expansion. This $1 trillion opportunity is pouring fuel on the fire of the geopolitical struggle for tech supremacy. And just this week, the United States made another move, a really controversial one, that shows you just how high the stakes have gotten.
So what's the latest shot fired in this war? Well, the U.S. Senate is now debating something called the GAIN AI Act. And the reasoning behind it is actually pretty simple. They're saying the demand for top-tier AI chips is so high that it's completely outstripping supply. And American companies are stuck waiting months to get their hands on the latest hardware. Their solution? It's radical. It's basically a legal right of first refusal. Think about it like this. The law would force companies like NVIDIA and AMD to serve their U.S. customers first, and only after the entire domestic backlog is cleared could they even think about applying for a license to sell those chips overseas. As you can probably guess, this whole idea has kicked off a massive debate. It really represents two completely different ways of seeing the world. On one side, you have the supporters who say this is all about national competitiveness. Brad Carson, a proponent of the act, put it really bluntly. He's saying, hey, every advanced chip we sell to another country is a chip we can't use right here to accelerate our own R&D. It's a classic zero-sum game perspective. But on the other side, NVIDIA is firing back, saying, whoa, hold on. That's not how it works at all. Their point is that selling globally doesn't take chips away from the US. It actually makes the whole pie bigger, which in the end helps American businesses. This is a perfect snapshot of the clash between free market ideas and this rising tide of techno-nationalism. And this pressure isn't just theoretical. It's hitting companies right now. Just this week, the US government went after TSMC's plant in Nanjing, China. They revoked its validated end-user status. Now, what does that mean? Well, think of VUE as a kind of VIP fast pass at the airport, a global entry for importing US chip-making equipment with almost no friction. Well, that fast lane is now officially closed. From now on, every single piece of US equipment headed to that fab needs its own individual license. This isn't just about creating annoying operational delays. It's a message, a warning shot really, that in this tech war, nobody's global footprint is safe. And with these new walls going up, the industry is responding by building new bridges. Alliances versus walls. The industry responds with collaboration. Right, so if governments are getting busy building walls, what's the industry doing? Well, they're getting creative. And they're building alliances. When the challenges get this big and the politics get this messy, the only way forward is to team up. And nowhere is that more true than in the new key battleground, advanced packaging.
So why all the fuss about packaging? Well, just follow the money. This isn't just about putting chips in a black box anymore. According to Yole Group, the advanced packaging market is set to just about double, growing from $46 billion this year to nearly $80 billion by 2030.
This is the new frontier for performance, and it's a strategic battleground that no major player can afford to sit out. And to go after that $80 billion prize, the industry just assembled its own version of the Avengers. A new consortium called Joint 3 was just established, led by the Japanese materials powerhouse Resonac. And just look at this roster. You've got Applied Materials, Lam Research, Synopsys, Tokyo Electron. I mean, it's a who's who of the semiconductor world. All 27 of these companies are the absolute titans of their fields, from materials to equipment to software. And they've come together for one reason: to join forces and conquer the absolutely immense challenges of next-generation packaging. So what's the big mission for our team of Avengers? It's something called panel-level packaging. Let me break it down for you because it's actually pretty simple to visualize. Think about making cookies. You could bake them one at a time on a tiny round pan, right? That's kind of like a traditional wafer. Or you could use a giant rectangular baking sheet and make dozens at once. That's panel-level packaging. It's all about massive efficiency and scale, getting way more chips for your buck, which is exactly what you need for these huge AI accelerators. And their goal is to build a prototype line for these massive panels. But all this collaboration on chiplets, it only works if everyone's Lego bricks can actually snap together, right? I mean, what good is it if they don't fit? That's the exact problem the Open Chiplet Economy Initiative is trying to solve. They're working to create a universal instruction manual, a universal standard, so that a chiplet from, say, Synopsys can play nice with one from AMD or Intel. Without that common language, a true multi-vendor Lego set is just impossible. And these alliances, these standards, they're all built on top of some incredible manufacturing breakthroughs. Technology that breaks barriers, the engines of innovation. Okay, so let's get into the nitty-gritty. What are the actual tech breakthroughs that make all of this possible? I mean, we're talking about stuff that's so mind-bendingly difficult and expensive that companies have to team up. These are the engines powering that trillion-dollar future. And this week, we saw a huge milestone right here. The Korean memory giant SK hynix announced they've successfully installed ASML's latest and greatest machine, the High-NA EUV tool. This thing is, and I am not exaggerating, the ultimate weapon in chip making. It's the only tool that can etch the patterns needed for 2-nanometer chips and beyond. What's so critical about this news is that SK hynix is planning to use this incredible tool, which costs north of $350 million, by the way, to make next-generation DRAM. This is a huge signal. It means the absolute bleeding edge of manufacturing tech is officially moving out of the R&D lab and onto the high-volume production line for memory.
So you've got these screaming fast chips. What's the next problem? Well, you've just created a massive data traffic jam. The old copper roads between the chips just can't handle the speed anymore. So the industry solution is to rip out the asphalt and install a light-speed fiber optic network. That's silicon photonics. The roadmap's pretty clear. By 2027, we'll see 1.6 terabit transceivers becoming common. And the endgame by 2030 is co-packaged optics, where the silicon and the optics are literally built into the same package.
And really, all these breakthroughs come down to 3 key pillars of advanced packaging. First, you've got chiplet architecture. The idea is simple. Stop trying to build one giant, perfect chip, and instead, build with smaller, more manageable Lego bricks. Second is 2.5 and 3D stacking. Basically, build skyscrapers, not just single-story ranch houses. Go vertical to shrink distances and boost speed. And finally, you have hybrid bonding. That's the superglue that connects all the floors of that skyscraper together with seamless, ultra-fast connections. These 3 pillars together are the foundation for everything coming next. All right, so the final question, gauging the industry's health. We've talked about the insane market projections, the geopolitical drama, and the incredible technology. So let's bring it all home and just put our finger on the pulse. How is the patient doing right now? Well, the data shows that despite all the tension, the growth story is stronger than ever. And hey, the numbers don't lie. Just look at this checkup for the second quarter. Global sales of semiconductor equipment, that's the tools you need to build the fabs, up a whopping 24% year over year. That's a leading indicator that tells you companies are investing heavily, building for the future. And the companies making that equipment, their revenue's up 20%. And finally, the foundries themselves, the ones actually cranking out the silicon, saw revenue jump almost 15% in just one quarter. The bottom line here is simple. Business is booming, from the top of the supply chain all the way down. And that brings us to the core tension, The story of our time, really. On one hand, you have the forces of competition, of nationalism, trying to build walls with things like the GAIN AI Act. On the other hand, you have the forces of innovation, of collaboration, trying to build bridges with alliances like Joint 3. It is a fundamental tug of war for the soul of the industry. So I'll leave you with this question to think about. As we race toward that trillion-dollar future, which one of these forces is going to win? Collaboration or competition? The answer to that question is going to shape everything for the next decade. And we will be following every single twist and turn of that story right here. So to make sure you stay on top of it, don't forget to subscribe to Dr. Pai's channel. Thanks for tuning in.